amplitude, wavelength, time period and frequency. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Firstly, let me teach you that what is amplitude. Well, consider the sound waves produced by the source. We know from the previous lecture that during wave motion, particles oscillate about their mean position or equilibrium position to produce sound waves. Now the maximum displacement of the particles either above or below from the mean position is called amplitude. I simply remember that amplitude is the maximum height above or below from the mean or equilibrium position. Usually, amplitude is denoted by x0. The SI unit of amplitude is meter. Now, how can we calculate or measure the amplitude of any wave? Well, consider these two waves. Now, I should measure the distance or length of this peak point from the mean position using a ruler or any measuring device. For example, when I measured the length of this peak point from the mean position, suppose it was 0.005 meter. So the amplitude of this wavelength is x is equal to 0.005 meter. Similarly, in this wave, to find its amplitude, we measure the length of this peak point from the mean position. Let's suppose that the length of this peak point from the mean position is 0.1 meter. So the amplitude of this wave is x is equal to 0.1 meter. Thus we can also state that the amplitude of this wave is smaller than the amplitude of this wave. Now what is wavelength? Well, consider the motion of these two waves. We know from the previous lecture that transverse waves travel in consecutive or successive crest and trough, while longitudinal waves travel in successive compression and rarefaction. In case of transverse waves, the length of successive crest and trough is called its wavelength, while in case of longitudinal waves, the length of successive compression and rarefaction is called its wavelength. Wavelength is denoted by the Greek letter lambda. Its SI unit is meter. We know that this region is crust and this region is trough. So the length of one crust and one trough is wavelength or lambda. Let's suppose that its wavelength lambda is equal to 0.01 meter. We also know that this region is compression and this region is rarefaction. So the length of one compression and one rarefaction is wavelength or lambda. Let's suppose that its wavelength lambda is equal to 0.002 meter. Thus remember that wavelength is the length of successive crust and trough, or it is the length of successive compression and rarefaction. Now what is time period? To understand the concept of time period, you must understand the concept of wave cycle. Let's consider the motion of these two waves. In case of transverse waves, one crest and one trough form one wave cycle or one oscillation, while in the case of longitudinal waves, one compression and one rarefaction form one wave cycle or one oscillation. Now, how many wave cycles or oscillations are there in transverse waves? And how many wave cycles or oscillations are there in longitudinal waves? Well, this crest and trough make one wave cycle. This crest and trough make another wave cycle. And this crest and trough also make another wave cycle. So there are 3 wave cycles or 3 oscillations in this transverse wave motion. Here, this compression and rarefaction make one wave cycle, and this compression and rarefaction make another wave cycle. So there are 2 wave cycles or 2 oscillations in this longitudinal wave motion. Now listen carefully. Time period is defined as time taken by the oscillating body to complete one wave cycle or one oscillation. Let me repeat it. Time taken by oscillating body to complete one wave cycle or one oscillation is called time period. Time period is denoted by capital T and its SI unit is second. For example, if this wave completes its one oscillation or one wave cycle in 2 seconds, then its time period is T is equal to 2 seconds. If this wave complete one oscillation or one wave cycle in 1 second, then its time period is T is equal to 1 second. Thus remember that time period is the time taken by oscillating body to complete one cycle. Finally, let me teach you that what is frequency. Well, consider the motion of these 3 waves. Let in 1 second, this wave completes 3 wave cycles or 3 oscillations. This wave in 1 second completes 4 wave cycles or 4 oscillations, while this wave in 1 second completes 6 oscillations or 6 wave cycles. We define frequency as number of wave cycles or number of oscillations completed in 1 second. Let me repeat it. Number of wave cycles or number of oscillations completed in 1 second. Frequency is denoted by small f. The SI unit of frequency is Hertz. Thus, the frequency of this wave motion is 3 Hz because it completes 3 oscillations in 1 second. The frequency of this wave is 4 Hz because it completes 4 oscillations in 1 second. And the frequency of this wave is 6 Hz because it completes 6 oscillations in 1 second. Also remember that frequency is equal to the reciprocal of time period. F is equal to 1 upon T. Thus frequency is the number of wave cycles or oscillations completed per second or 1 second. This was all about amplitude, wavelength, time period and frequency.